And on behalf of Anderson Windows, who is presenting this class, I want to thank all of you for coming. My name is Eric Stafford, as Wendy said, and I've been giving webinars for AIA for quite some time. And most of the times we'll focus on codes or something to do with wind loads. The presentation today, we're going to talk, spend well, nearly all the time talking about how can we simplify the wind provisions in the building code, right? Because I don't think I'm going to turn my video off just so everything runs smooth here going forward. But I don't think I've ever heard anyone say, man, these wind provisions in the code are simple. Maybe I've heard them say they're maybe a little more simple than rocket science, but in general they're pretty complicated. So we're going to talk about that and a tool that Anderson has developed that's free of charge. Introduced it last year. And it was, at the time we were talking about it for the fall webinar, the fall webinars we did, my recollection is it wasn't quite ready, but now it's up, running, fully functional, ready to use. Okay. So some of the key topics we're going to talk about today, I want to talk about wind speed versus wind loads, questions that come up. And then we're going to focus the remainder of the webinar on this simplification that I've been talking about. As Wendy said, if you have any questions, feel free to type them up at any time during the webinar. As we move on from different points, I'll try to check the Q&A just periodically, but we should have plenty of time at the end for any questions that you have, even some that might relate to wind loads or something might not pertain to the presentation today. Okay. Try to advance. There we go. All right. So, how many of you have ever heard, and I know most of you probably know the difference, but um, how many of you have ever heard an owner ask for a building or a window or some product that will withstand a category 3? I want cat 4 windows. I want cat 5 windows. I want a cat 5 building, right? It comes up all the time. Professionals like yourself and the rest of us, we know that's just not possible, but what the general public, I shouldn't say it's not possible. It's not straightforward is a better way to put it. And we'll talk about that in just a minute. But, the public sees when hurricanes are approaching and on the news, it's a cat 2 now, it's a cat 3 with sustains wind speeds that range from, whatever the ranges are for the different categories. Okay. So that's how the public relates to hurricanes and wind loads. But we know that particularly for windows and doors, that is a myth. We do not rate windows and doors or really anything for different wind speeds or hurricane categories. The one exception being asphalt shingles, which are rated for wind speeds. But most products on the building are rated for design pressure, right? And windows and doors, they're tested, designed, and they're rated for design pressures as required by the building code. They are not rated for a specific wind speed or hurricane category. Now, you could, someone wanted category 4 windows. If you narrow the scope of what you're looking at, um, you could probably provide something, but it would be for that specific case. It might not work for their neighbor's house. Their neighbor's house might be 2 stories, and the window you picked might be good for a category 4, if that makes sense. Category 4 storm in this one house, 2 houses down, it might not work, right? Because there are so many factors that affect what design wind pressures are, and that's what we rate windows and doors to. There's a couple of fact sheets. You can find these and there's quite a few others. It's buildingasaferflorida.org. It's a group that's funded by the Florida Building Commission. They put together different fact sheets and different guides And one of the one that I'm referring to here, Windows and Doors 101 for consumers, talks a little bit about what we're talking about now about yeah, windows and doors not being rated for hurricane categories, and also goes into some additional items that are important to try to bring the public kind of up to speed as to what we actually do. Because if someone tells you they've got a category for a window, you need to start asking some more questions. Not that they're lying, but it's that's not how we rate windows and doors or most other products that are installed on the building envelope. So I mentioned that it wasn't straightforward because there are just so many things that affect the design pressure, which is what we're interested in, the design pressure on the building. If you have the building height, an increase in building height results in an increase in design wind pressure. The window or door size. And this seems counterintuitive to most people, but as the design wind pressures increase, I mean, as the window size decreases, design wind pressures decrease. Like I said, that seems counterintuitive. Most of the people think or tend to want to think, well, if I had a bigger window, it seems like it would be a higher design pressure. But the reality is, and let me just do a little sketch right here. So if we're looking at, how's my pen up? There we go. We're looking at like if the wind is blowing on this wall here, and let's say there's a window located in this wall, the actual pressures that are occurring on the wall and the codes, we assume it's like this uniform 10 PSF, 20 PSF, whatever the number is. But what it actually looks like is something like this. It's very irregular. So you might have high pressures up here, high pressures here, low pressures here, right? So if you average over the peaks and the troughs, you get an average that's somewhere right here. So if you average over the whole wall, if you take a smaller section and you average over here, then your number is higher. Okay, so that's the main reason that for smaller effective wind areas or smaller windows and doors, the design wind pressures are higher. Also, the location on the building. The design wind pressures are higher for windows and doors that are located near building corners. As the wind moves around a building, these vortexes are created at corners, on roofs, and on walls, and result in higher design pressure. So we have what we've seen in the code, zone 5 versus zone 4, which is kind of in the middle of the building. The other key factor is the surrounding terrain, which significantly affects design pressures on every component on the building, which is the exposure category. Are you located, within an area where there's lots of other buildings and lots of other trees, or are you kind of out in the open in the field, or are you near a large body of water? So, and we've talked about some of these on some of the previous webinars. Let's see if I can. There we go. Scratch this out. Thought it was going to carry forward with the screen. But and we've talked about these exposure categories on several webinars in the past, right? And I'll come back to that other slide in just a few minutes. But our best exposure category is where we have exposure category B. So we have all these trees, buildings, and at least it has to be in 1,500 feet in all directions for single family dwellings, for example. That they all slow down the flow of wind and result in the lowest design pressure for any of our exposure category. Our open water or exposure D type category, this is where you're near a large body of water that extends, for 5,000 feet. And if you're within 600 feet of that large body of water, and that could be the ocean, that could be a large inland lake. And we've learned through the really the windborne debris issue that came up last year as a result of adoption of ASCE 722, that there are lots and lots of lakes in Central Florida that meet that criteria, that have that 5,000 foot of width to give you the exposure D category. Now, while the windward debris region stuff has been put on hold for now, the exposure categories haven't. Okay, so exposure D would still apply in all these areas. So all of these components, the exposure, the height, the where did I go? There we go. Coming back to this, the height of the building, the where it's located within in relationship to a corner, all these things affect the design pressure. Okay, so you might, you know, taking into account all these things, you come up with a design pressure for a specific condition. So trying to put together a set of conditions that will work for every situation that you might come up with to call it a category 4 window or a category 4 building, you know, can be quite challenging. Because it would matter where it's located, its wind speed, and then to add on top of that, I don't know if we've ever talked about this before, but the wind speeds that we get from the Saffir-Simpson hurricane category, that's the ones that the general public are familiar with. These are actually sustained winds. These are sustained wind speeds. They're average wind speeds over a 1 minute period, and they collect this data, drop signs and other technology. I think primarily through drop signs. They drop these devices from the planes, drop them out of the sky, and they drop down in the hurricane and measure the various parameters that they're looking for. Okay, um, the wind speeds we use in the code are 3-second gusts. Okay, so this table here, I kind of put it together from some information that was in the back of ASE 7. The wind speeds in the code don't match up exactly with the Hurricane Simpson, the Saffir-Simpson hurricane category wind speeds. As you can see, for a Cat 5, you know, the sustained wind speed is 157 miles per hour. We're talking about, you know, something comparable to that in the Florida Building Code is 173 miles per hour. Okay, so it's not easy to make that connection if you don't know exactly what you're doing. Okay, all right. So let me just check the Q&A real quick just to make sure there's nothing in there. Looks good. All right. So let's talk about you know, design wind loads for windows and doors and how can we simplify how we determine wind loads for windows and doors. In the code, we can use ASE 722. And if you've ever looked at it, pretty complicated. It's not straightforward by any stretch. Um, we do have a simplified table in the code, which is, you know, pretty simple, but it's not as complicated, but still a lot of numbers, as we'll see in a few minutes. And you're going to have to do interpolation from time to time. And then you'll have, for different exposures and different heights, you're going to have to multiply the table value by some other number, and you might have to do multiple interpolations. Okay. But there's an easier option that, like I said, I introduced it last fall, the Anderson Windy app. And we're going to take a look at that and look at some examples after we talk about the code here in a second. All right, come on. There we go. So if you went to ASE 7 to calculate design pressure on windows and doors, this is what you would see. Okay, and this is a summary of what you would see. It gets pretty complicated. You know, two key equations. Ultimately, we're looking for design wind pressure, right? But then we got all these parameters that we have to put in. The height and exposure coefficient, topographic factor, typically doesn't apply in Florida, but might in a few areas. The elevation factor, directionality factor, and then the external and internal pressure coefficient. And a lot of these vary depending on the size of the window, the size of the door, whether it's zone 4, whether it's zone 5, those sorts of things. So it gets pretty complicated to try to figure out how to calculate a design pressure using ASE 7. That's one of the reasons the code years ago, actually all the way back to the original 2000 IRC, and the 2001 Florida Building Code, we've had a simplified table for residential buildings. Okay, and you can pick a design pressure out of a table, but you still may have to modify it, and you may have to do interpolation if your wind speed is between 120 and 130. You can either use the higher number, or you are allowed to interpolate. Okay, and then we're dealing with effective wind area. Let's say your effective wind area was 15 square feet. The table gives you values for 10, 20, 50, and 100. So this one works a little bit backwards, because if your effective wind area was 15 square feet and you didn't want to interpolate, you actually use the lower effective wind area because you're going to get a higher design pressure. Okay, so all these things wind up creating some complexity that just makes it difficult to figure out from time to time. And as I mentioned earlier, this table is for this slide here kind of shows how this table works, but it's for a mean roof height of 30 feet and for exposure category B. Okay. And if your mean roof height is other than 30 feet, less than 30 feet, greater than 30 feet, or if your exposure category is something other than B, then you'll have to go to this table here, and whatever your mean roof height is, read across your exposure category, and that would be the factor you'd multiply the design pressures in the tables by. Okay, may have to do some interpolation here as well. So this is much simpler. At least we're just dealing with numbers. This is much simpler than this, but it's still a little bit complicated, a little bit, a lot of numbers. How we used to do that with this, as big as the table is, how we used to do this with hard copies and not having a PDF to be able to zoom in. I don't remember how in the world I was able to, well, 25 years ago, my eyes were a lot better than they are right now. But greatly appreciate the zoom feature on the PDF, or being able to see these small numbers in this table. Okay. So, but as I mentioned here, this table is for a mean roof height. It gives you a mean roof height of 30 feet, exposure category B. It tabulates loads for the two zones, zone 4, zone 5, and effective wind areas of 10, 20, 50, and 100 square feet. Okay. Another key thing is that these loads are ASD loads. Okay. Um, we pretty much done that with everything in the code, even though we're using strength design wind speeds. Most everybody is still using ASD loads in some form or fashion. Even I know you'll see commercial buildings that are being designed to the LRFD method, or strength design. But most everything done with residential and wood frame in particular is going to be done the ASD level. So you're going to see this for pretty much all the various simplified tables we have in the code. So what that means in effect is that after the design wind pressures have been calculated in accordance with ASC 7, they've been multiplied by 0.6 to convert that down to an ASD level. Okay. So let's look at a couple of examples, and I mentioned this earlier. This is an excerpt of the component cladding pressure zones. There's also figures for the roof, but just excerpted the one for the walls, where we have zone 5 and zone 4, and zone 5 for residential, it can be taken around 4 feet. Code says you can take it at 4 feet, but it's in and of itself is a pretty complicated variable to determine, because it's based on the geometry of the building. And but 3 feet is the minimum in ASC 7. In the IRC, we say take it at 4 feet. Okay, so anything within 4 feet of a corner. And one thing I'll mention too, because this comes up a lot, these zone 5 only applies to exterior corners. Okay. It does not apply to an interior corner. You don't, when the wind is blowing in those areas, you don't get those vortexes created by the wind being separated as it try and negotiate that corner. So zone five only applies to exterior corners and not an interior corner of say an L-shaped building. That interior corner, zone five would not apply there. Okay. So the reality is let me get my pen back up here. Uh, the reality is that the load on this area here, this zone five here, is caused by the wind blowing from this direction. As the wind comes around, it hits this wall here, and a vortex is created as it goes around the side of the building and results in these higher negative wind pressure. The same applies for all the corners. Okay. All right. So let's take a look at how a couple examples of how this table works. So I just picked something simple, something easy to look at. But you could have picked any different variables to work with this table. But let's say we have a wind speed of 140 miles per hour, exposure category B, mean roof height of 30 feet. And let's say our window and door size is about 10 square feet. And where it's going to be located in zone five. And it's also an enclosed building, which is another important thing we didn't talk about, but um, you don't see that a lot in residential because if you're in a windborne debris region, you're now required, you have been for quite some time to have impact protection. So we're not allowed to design partially enclosed building for the most part for one and two family dwellings anyway. But it does have to be an enclosed building. All right, so we've got these parameters: wind speed 140 miles per hour, exposure category B, mean roof height of 30 feet, effective wind area 10 square feet in zone five. So we go to the simplified table, and I've just kind of taken out a piece of it, an excerpt, because it's so big, it will take up the most of the screen. But we look over for get my pen here again. Wind speed of 140 miles per hour. We said zone five, effective wind area of 10 square feet, and we read across. And our design wind pressures are positive 21.2 PSF and negative 28.3 PSF. Okay. So that one was pretty simple. You know, the things that made it simple are the fact that our exposure category was B and our mean roof height was 30 feet, which is the basis of this table, right? As long as we stick with those parameters, it winds up being pretty simple. But what happens if we change the mean roof height or change the exposure category like we're going to do in this example here? So now let's say we have we're going to use the same wind speed of 140 miles per hour, but we're going to say it's in exposure D. So it's near it's within 600 feet of some large body of water that extends for at least 5,000 feet, and a mean roof height of 40 feet and effective wind area of 15 square feet. Okay. I have to erase everything to get the screen to slide. Okay. So we come to the table, and now we have our effective wind area is between two of the ones listed. It is, excuse me, it's 15 square feet, so it's in between here for zone five and 140 miles per hour. So it's the same part of the table we were looking at earlier, but now we have to interpolate between these values. So it's halfway between here and halfway between here because it's 15 square feet. So we get table values of 20.7 positive and 27.4 negative. But we've only done part of what we need to do. We said we had a mean roof height of 40 feet and exposure category D. So we'll have to go, excuse me, to the next table and our height and adjustment factor table. And we're exposure D. So we're over here in the far right column. And then we said we had a mean roof height of 40 feet So we read across, we have to multiply our table values by 1.74. Okay. So we take the ones before 20.7 and negative 20, negative 20, 27.4 PSF, multiply them times 1.74, and we get our minimum design pressures. Okay. So a product that would have to have a design pressure rating that was a minimum plus 36 and a minimum negative 47 or negative 48 PSF. Okay. And if you went through the calculations in ASC 7, you would pretty much get something slightly lower than what we got here. But and the reason for that is because we had to interpolate the the effective wind area. Now, when I say slightly, I mean it might be zero point 0.4 or zero point 0.5 PSF. I mean it's that little of a difference at that level. But we're using linear in interpolation and the to get the effect the value between the effective wind areas listed, and it's actually a log graph that the external pressure coefficients are on. Okay, so it's not linear, but it will be conservative, but just ever so slightly. Okay. So again, much more simple than ASC 7, but again, we have to pick these numbers out of the table, and then we have to interpolate, and then we have to multiply them times values in a separate table if we're outside of the parameters of the table. Okay. All right, I just want to make sure there's no, there are a couple of question and answers. Isn't there an ASCE app lookup by, yeah, okay, yeah, we're actually about to get into that. The question was, isn't there an ASCE app lookup by address? One thing I will point out, since you asked the question, all that ASCE app does is give you wind speed. It will not give you the design pressure, okay? And we're going to talk about that in just a few minutes, okay? So having said all this, and like I said, the simplified table in the code it's more simple, but it's still kind of complicated and it's tedious. Let's say you're working on a project where you've got multiple window sizes, and you're having to interpolate or take the worst case for each one, and I mean, it can be at the very least tedious. So I want to show you guys this new tool that Anderson has put together. It's called the Windy app, and it's a window and door design pressure calculator. And the one of the key things I like to point out is the free tool from Anderson. You can go to this website down here. Windy.andersonwindows.com, and you can log in, you create an account, you establish a username and password, and you're off to the races on what I'm about to show you. Okay. There are three key parts of it. There's a simple wind speed lookup, simple design pressure calculation, and you can do the project option where you have multiple windows throughout a building. And like that example I gave you earlier about having to look through that large table in the code for where you had multiple products you're trying to deal with. So that product auction will make that a lot easier in Windy. Okay, so we're gonna let me have to every time I have to, for some reason I'm having to erase the my handwritten notes to advance the slide. So sorry about that. So there is a new note in the code that permits the use of these databases to determine wind speed, right? And most places have been using. Most everybody's been using the ATC site. The people that have been using these wind speed databases have been using ATC for probably close to 12 or 13 years, right? ATC developed the first one for ASC 710, and it was a couple of years after ASC 710 came out. So I think it was around 2011 or 2012. And so they did ASC 710 and ASC 716, but They are not and will not be updating the ATC hazard tool for ASC 722. And in fact, I was under the impression that they were going to continue operating and maintaining the site, even though we're still going to be limited to ASC 710 and ASC 716. But I was on the site. I tried to get on the site the other day, and it's no longer operational. It's down, and they tell you to go to the hazard tool. Okay, which is what somebody mentioned a few minutes ago. So I say this, but the code is moving closer, you know, to a lot of these databases. We know they're helpful. We know they're easier. We know they're more accurate. Now, yeah, 30 years ago, when I first learned about wind speed maps in the building code, like I said, we did not have PDFs, or at least that I had access to, where you could at least zoom in on that map in the code. We just had to look at the piece of paper and try to guess what the wind speed was if you're in between the contours. Um, but we've come a long way since then, and now the Florida Building Code added a new note that specifically says you can use the hazard tool to determine your wind speeds, or some equivalent. Okay, but like I said, the difference between what I'm going to show you today, and I'm going to do an example with the hazard tool as well, is that hazard tool is only going to give you wind speeds. Okay. But for those of you who've used the ATC side in the past, you know, for one, you weren't going to be able to use it moving forward in Florida because Florida has adopted ASC 722. And two, now it appears it's not operational anymore. Okay. So I mentioned this earlier, but when you log into the Windy app, this is kind of what you see. You've got three options there. If you're looking for, you just want to know what the wind speed is and some location, without complication, you can just click on this link. You put the address in and which version of ASC 7 Windy gives you. Will give you wind speeds and design pressures for ASC 710, ASC 716, and ASC 722. And then if you were also just you want to do a quick check on the what kind of design pressure you needed for some window or door. You don't want to go through the process of creating a project, but you're just curious what it's going to be on this window or door. Then you can do that through this quick calculate window or door design pressure. You just have to put the key parameters in. And then if you're looking for something a little bit bigger, you can create a project where you can add in multiple units. And I'll show you some of this here in a few minutes. Multiple units, and at the end you would click calculate, and then to give you the required design wind pressures for all of the units that you inputted. Okay. So if we went to the first page, let's say calculating a wind speed in the Windy app, you can put in a very specific address, or you can put in a general address like Gainesville, Florida, or Tampa, Florida, just like you can with the hazard tool. And it'll give you a wind speed, right? This is the wind speed from Windy, and go into the hazard tool. And I'm going to pull up a couple of these here in just a minute. But I point this out here because occasionally there are slight differences between the hazard tool and Windy app and other wind speed databases. And it has to do with how the interpolation is done between the contours. So as you can imagine, that these databases don't have every single point house located within the database, but the wind speed contours on the map are geolocated, and then each of these wind speed databases uses an interpolation algorithm to interpolate between the contours. So they are a little bit different. ATC gave you a little bit different wind speeds than ASC 7 did as well. Okay. All right, give me 1 second, and Erase this so I can move forward. All right. So let's take a quick look at the Anderson app, okay? And this is or the Windy app, and just kind of going through the quick design pressure calculation box that we talked about, okay? And I'm going to drop off and get on the app here in just a minute, but just want to kind of introduce it to you. So you can you'll have to input the address, and it can be, a specific address like what we have here, or you can put in a general address such as Gainesville, Florida, and it'll just give you the wind speed based on the geographic center of the city of Gainesville. You pick the ASCE 7 edition you're interested in. You can pick 710, 716, or 722. Not long, we'll be picking ASC 728, believe it or not. And then, of course, we have to pick which wind speed map do we want to use, risk category 2 map, 3 map, or 4 map. And then we uh, um, uh, specify our exposure category, B, C, or D, our mean roof height, and then our unit size. Okay, these are all the parameters that we're going to need to determine what the design wind pressure is. Now, also note, if you want to enter a manual wind speed, let's say you're in Miami-Dade County, right? And Miami-Dade County requires you, or in Broward, but Miami-Dade requires the use of, for risk category 2, 175 miles per hour wind speed countywide. So all you have to do is click on this manual wind speed box here, and then you can input a manual wind speed to use that'll do all the calculations for you. Okay. Right. Miss one. And then after you click calculate, your results page pops up, and we see, like we talked about earlier, our wind speed is 124 miles per, not too far, 124 miles per hour. And our design wind pressures are for zone 4 and zone 5 are plus 16, minus 16, or plus 16 PSF, and our negative design pressures for zone 4 and zone 5 are negative 18 and negative 22.2 PSF respectively. Okay. And then also, I mean, if you ever wanted to use this for any permit type situation or whatever, it also gives you the values and assumptions used for the design pressure calculations. What the external pressure coefficients were that went into this equation, the internal pressure coefficient, the velocity pressure coefficient, everything that was used to calculate that design wind pressure is listed here. Okay. So let's go. And did I mention, I think I mentioned this, but I'll mention it again. This app is free. It doesn't cost anything. All you've got to do is, let me get out of here. Stop share. I'm going to share a different screen. Bear with me for just 1 second. Here we go. Okay. No, I'm sharing the wrong thing again. Hold on 1 second. Sorry about this, guys. PowerPoint. Yeah. Okay. Here we go. Now I'm on the right one. All right. So I'm going to go to home here. So I'm logged in on the Windy app. And like I pointed out to you earlier, you can calculate your wind. You can do a simple wind speed lookup, simple design pressure lookup, and you can create a project. So if we want to create a project, it winds up, kind of working the same way. You just got one more button that where you would create use to create a project. We'll call this the project 2. And it works anywhere in Florida, but it also works anywhere in the United States unless you're in a special wind region. So let's just do 2038. We'll do this address here. Club Road, Hoover, Alabama, which is close to me, over Birmingham, Alabama. I'm going to use ASE 722. We had a mean roof height of 30 feet. We're going to do risk category 2 and exposure category B. Then we save that. I went through that pretty quickly because we had already kind of been through that. Okay, so now we have some of the key parameters, but we don't have everything. So we're creating a project. Let's say we're going to have multiple windows and doors. So let's just say door 1, and I'll just say 15 square feet. We're going to save and add a unit, door 2, and we'll call this door 2. And we'll do this one 20. I'm just adding some numbers here. And then door 3. And you can add, I don't know what the limit is on how many you can add. It may not be a limit. Door 3. Oh, I'm sorry, I already had door 3 and to do 30. And then let's say save. And then after we have everything put in, we can click calculate. And then we have for each individual door, we have, let me move this a little bit. For each individual door, we have the positive and negative design wind pressures. Door 1, door 2, and door 3. Okay. So as you can see, this actually doesn't get a lot simpler. And some of you might ask, well, how does this match up with ASE 7? Well, it actually matches up exactly. The equations that are the backbone to uh, create design pressures. They come directly from ASE 7. And in fact, the um, um, the the equations for the graphs are included in here, and the equations for the velocity pressure exposure coefficient. So it actually couldn't get more exact to ASE 7. It will differ slightly from from the simplified table if you pick an exposure category, not exposure category, an effective wind area that's in between the ones uh, specified in the table. Like we said, if you pick 15, so it's you would do linear interpolation on the table, but the windy is going to use that log graph. So you're going to get slightly different numbers, but they're going to be very, very small differences. But if you pick values that are in the table, 10, 20, 50, and 100 square feet, you're going to get the exact same number that's in the table. Okay. All right. So I mentioned the hazard tool as well, just to show you. I want to point out a couple of things. There are a couple of things I want to point out here. Um, let's pick something a little bit further down. So Orlando, Florida. So the hazard tool will give you quite a few things from ASE 7. You can pick seismic parameters, snow parameters, but for none of these things is it going to give you, and you pick the risk category here in the ASE 7 version, but for none of these is it going to give you the loads that you need. All it's going to give you is some of the key parameters, and the key parameter that it gives you for wind is the wind speed. Okay. Now you can do an overlay here, but um, it's not going to give you design wind pressures. Okay. And there are a couple of places in the hazard tool in Florida, unfortunately, that are a little problematic. Um, and it's areas if you click on this overlay and these interpolation tools, and there's a couple other places in the country where it's a little bit of a problem as well. These interpolation tools, they interpolate great when the lines are parallel to each other. Um, where they're not parallel, some of them run into some problems. Okay, so let's pick Lakeland for example. Okay, let me see if my which is it's kind of in this purple area through here, but it's it's less than 140, but greater than 130. So I think Lakeland might be one of the ones I looked at. Lakeland, Florida. And then we click view results. Yes, Lakeland is one of them. So the hazard tool, and this has been brought up by a number of other people a couple of years ago, but ASE hasn't fixed it yet. So Lakeland clearly is less than 140 miles per hour, but the hazard tool is telling you the wind speed is 140 miles per hour, and it makes it even more problematic because the 140 mile per hour contours are trigger for windborne debris. So if we go to the Windy app, let's go back to home, and we're just going to do simple wind speed lookup. I'll just put in Lakeland, Florida, and risk category 2, view wind speed. And you see the Windy app gives us 137 miles per hour, if y'all can see that. Let me annotate, get my, so you can see the wind, which is, you know, 3 miles per hour, like overall, not a huge difference in wind speed. But, you know, in terms of whether or not you're in the windborne debris region, it's a pretty big deal. Okay. So that's really the only area I know of in Florida where there's a major problem with the hazard tool, but I know in the Northeast there are some areas where it's a little problematic as well. Okay. All right. So one more thing I'm going to touch on, and I'm going to open it up for some questions. I'm going to go stop sharing and go back. Go back to the other slide. All right. Let me get in presentation mode here. All right, thanks for being patient with me, guys. Last thing I want to point out is some of the key parts on the label related to what we talked about today. And the supplemental label, the temporary supplemental label, this has all the key information on it related to design pressure rating and the Florida product approval number. This is the big label you'll see when windows are installed. And I've got, I mean, get the annotate button again. So the design pressure ratings obviously have to meet or exceed whatever the required design pressure is, whether you determine it from windy or from an engineer or from the architect or from the simplified table in the code. This DP rating here has to equal or exceed that. The PG rating should also be the PG rating is something you guys probably may or may not be familiar with, but it's the lower value from air, water, or structural. So it should be close or right at the positive design pressure rating as well. And then, of course, the impact rating criteria shown on this temporary supplemental label, Missile D, Wind Zone 4. That means it's good for Miami-Dade County. And then also the Florida product approval number. Okay. And with that, I'm going to open it up for questions. And I'm not sure why my annotations were not following each slide. They have done this before and they usually do, but hope that wasn't too much of a bother for you guys. But I'm going to open it up for questions and pull up the Q&A. Let's see. There are quite a few here. I think 1153. Okay, 1130. All right, I'm gonna start from the top and go down. Do you select the largest window size and worst location and then spec all the other windows to match that criteria for insurance purposes? Yeah, I can't really speak on insurance purposes, but for what I know, I don't know that to be what I understand that to be a concern for the insurance on the insurance side of things. I don't know. But I think I showed, and you may have asked this question before. I showed this on the Windy app. You can create a project and you can put in the specific window size for each and every window that you have. So you don't have to pick the worst case or the worst location. Okay. Um, Let's see. Next question. Are the pressures displayed in Windy ASD? Yes. Yes. Good point. Meant to mention that. They are also ASD level pressure, so they match up with the pressure, the design pressure ratings that I just showed you on the label. Those are ASD level pressures on the label. So what's in Windy as what's in the code matches and are ASD level pressures. All right, next one. What are the intervals that windows and doors are fabricated without getting into special order projects? Yeah, fortunately, and I don't know if, and she may not have the answer to this, but I do have Michelle Hunt with Anderson on this call or on this webinar. Michelle, is this something that you might could answer? I don't know what the
Yeah, it's going to depend on the product series. So be best to reach out through an Anderson sales rep or on the website and see if you can acquire that way. If there's a specific product series that you're interested in, feel free to drop that in the chat and I can look into it and respond later.
Thank you, Michelle.
You're welcome.
All right, now last question actually have three questions. So is the tool using part 1 or part 2 of ASC 7 chapter 30? It's using both. It's for buildings of any mean roof height. So when you put in your mean roof height of less than 60 feet, it's using the set of equations that are applicable for part 1, I believe it is, and which are buildings less than 60 feet in height. As soon as you hit 60.1, 60.2, whatever you put in that's over 60 feet, then it's using the buildings greater than 60 feet in height component cladding load pressures. Okay. And it's that's done seamlessly. You don't even know it's taking place unless you look at the output, and you'll notice that the pressure coefficients are a little bit different than and some of the values are a little bit different than the under 60 feet. Do we get an option for buildings over 60 feet? Just answered that. Can we get updated pressures for each level based on the window elevation above ground? And yes, you can. You can do that. Renewable Anderson, the frequent advertiser in the Central Florida region. Okay. I think, unless I'm missing any, Wendy, are there any in the chat, or is that pretty much it?
I think you got it all. Thank you, everybody, for putting your comments or your questions in the Q&A box. So that was helpful. But I think you covered them all.
Okay. Well, we got a couple of minutes left. If anybody has another question, feel free to ask it. Otherwise, we're pretty close to time, Wendy. Your call. If you want to wait a few minutes or whatever you want to do.
Well, I have a couple, quick reminders for everybody. So if anybody does have another question, feel free to go ahead and type it in the Q&A box for Eric or for AIA staff. But just as another quick reminder about your attendance today, that we will run a report that'll tell us when you logged in and when you logged out. So as long as you are with us for at least 50 minutes, we will submit your credits to AIA for AIA members. And for a certificate, if you need a certificate, please send an email to Hillary, and her email address is hgill@aiafla.org. The recording of the presentation will be available on our webinars page on our website. Just give us a few days to get those up and edited and up, and you're welcome to have it as a reference. It's not for CE credit, but it does. It is good to have, just to have to go back and look at. The material from today is downloadable in the resources tab you should see on your screen. There will also be an email that you will receive tomorrow that also has the material that you can download. Speaking of that email, and also when you hang up or when you log out of the webinar, there'll be a survey. We really appreciate you taking the 10 seconds to fill that out, to give us your feedback. That's very important to us. Just give us that extra feedback. If not, you'll probably hear from me just to give you another little nudge to please fill out that survey. That's how important it is that we get that information from you. So I think there is one more question if you want to go ahead and
Okay.
Eric, see that.
All right. Okay. Are the window pressures rated for wind and or rain, or whichever is lower of the two? That's where that PG rating comes in. And yes, they are tested for air, water, structural, and forced entry, and a few other things. But the PG rating is the lowest of the air, water, and the structural, and often limited by water. But they're tested for wind and rain, both of them.
Okay.
All right. Well, again, thanks, Wendy. Thank all of you on behalf of Anderson. Thanks for coming. And Wendy had that. If you run into issues with using the Wendy app, or you have more questions about the Wendy app, I think AIA has my email address. I usually put it up on one of these slides, and I think I forgot to do it this time. But feel free to reach out and with any questions. And thanks again for having us.